Hello students, in this video we will study about de Broglie's wave equation. Now what is de Broglie's wave equation? It is also in dual nature. It is going to show you that the matter exists as a wave also. This is a dual nature, that is the particle is behaving as wave. So this is what we studied earlier about Einstein's photoelectric equation and all the other things we did, and this is the last concept, de Broglie's wave equation. Now what is de Broglie's wave equation? Very simple. The wavelength of the wave is equal to h upon mv, where h is Planck's constant and mv is the momentum of the particle. We are comparing the wavelength belongs to the wave, right, and momentum belongs to the particle, and we are comparing the particle with the wave and wave on the particle, the interrelationship between them. Now lambda is equal to h upon mv or h upon p, because p is m into v linear momentum. Okay, now what I am going to do here, we will derive this equation, de Broglie's wave equation. Okay, how do we do that? So we know that Planck's quantum theory, energy is equal to h nu. This is nothing but h c upon lambda, that is h c upon lambda. Frequency is this much. Let us call this as equation number 1. Let us move further from Einstein's mass energy relation. What is Einstein's mass energy relation? Very famous equation, E is equal to mc square. Whenever you think of Albert Einstein, the equation comes in our mind is E is equal to mc square. Let us call this as equation number 2. Now we will compare these two equations. Okay, comparing equation 1 and equation 2. What we get? hc upon lambda is equal to mc square, right? So c gets cancelled here. So we have h upon lambda. Okay, h upon lambda is equal to m into c. We want lambda. Let us take lambda over there. You will get lambda is equal to h upon mc. C is velocity of light. That is 3 into 10 power 8 meter per second. So that is the maximum velocity for a body whose velocity v is less than velocity of light. Okay, the electron cannot travel with the velocity of light. Okay, so it will be much less than that. So that is why I say the condition velocity is less than the velocity of light, velocity of the particle. So I can replace lambda is equal to h upon mv, and this is the formula. We call it as de Broglie's wave equation. Okay, so we know that P is equal to m into v, mass into velocity. So we can write it as lambda is equal to h upon p. So this is the basic equation derivation. Now further to this, we have to connect the wave equation, wavelength, with the energy, because when we take any experiment, the energy of the particle plays a significant role. The energy can be either kinetic energy or potential energy. So let me now extend this equation and express this in terms of energy. Then how the equation will transform. This is what we are going to study now. Yeah. Okay, let me again rewrite it for you. Okay, again let me rewrite it for you, the basic equation, and then from there I will proceed to the energy equation. Okay, so we know that lambda is equal to h upon p or h upon mv. Fine, this is the primary equation. Now I am going to express this in terms of energy. Tell me, what is kinetic energy? Kinetic energy is half m into v square. Okay, very simple. What I am going to do, I am going to multiply this by m and divide by m, right? Mass. Okay, so that is equal to half into m. I bring it together, m square v square upon m. That is equal to half into m into v the whole square upon m. What is this? This is kinetic energy. Fine. So I can say, what is m into v? M into v is p. Okay. So I can write that kinetic energy is equal to, let me just check it here. Kinetic energy is equal to half into mv the whole square, that is p square divided by m. Okay, you get my point here. Here I put for mv, I put p, so p square upon m has come, that is kinetic energy. So I want this equation to be here only, p square, keep it here, bring 2 into m over here, you get 2m into kinetic energy. So what does this imply? P is equal to, p square is equal to 2mke, or P is equal to under root 2mke. Ke is the kinetic energy and m is the mass of the particle we have taken, is the electron here. So we will substitute in the first equation. We get lambda is equal to h upon under root 2mke. So this is the formula where it is kinetic energy is involved. Kinetic energy of the particle is involved, because finding velocity is much more difficult, but kinetic energy can be easily calculated. Okay, if it is not kinetic energy, if it is potential energy, then the formula will just modify h upon root 2m. What is kinetic energy? It is nothing but potential energy E into V. So we will put it E capital V, where E is electronic charge and V is the potential with which you are accelerating the particle. So this is the whole process which we have to learn. One is lambda is equal to h upon root 2m ke, and another is h upon root 2m ev. Here h upon under root 2m ke and h upon under root 2m e into v. If kinetic energy is given, use this formula, and if potential is given, use this formula. And I want to complete this video by stating a point here. All this can be experimentally verified, and there is an experiment called Davison and Germer's experiment. Okay, this experiment proves that the electrons behaves as wave. This is not in the syllabus of this year, so you just know that Davison and Germer's experiment will prove that matter waves exist. Okay, with this we have completed the dual nature of matter and radiation. Thank you so much.